So here is another question on projectile motion with angular projection. So it is given that show that a ball will go 3 times as high when thrown at an angle of 60 degree as to when thrown at an angle of 30 degree. But in both the cases it will travel the same distance in the horizontal plane. So basically what it is saying is that when the ball is thrown at an angle of 60 degree, the maximum height will be 3 times that much as when the ball is thrown at an angle of 30 degree. But in both the cases, the horizontal range will stay the same, and we have to prove it, mathematically here. Okay, so first, the formula for maximum height. There are two parameters here, maximum height and horizontal range. So the formula for maximum height Hmax is equal to u square sine square theta by 2g. This is the formula for maximum height. Now for theta equals to 30 degree, let's say, what is the maximum height? So Hmax for 30 degree is equal to u square sine 30 degree square by 2g. Because everything else is the same, the projection velocity is the same, everything else is the same. So in both the cases, the projection angle with respect to the horizontal, that is different. So it is u square into sine 30 is 1 by 2 square by 2g, which is equal to u square by 8g, or 1 by 8 u square by g. You can write it in this way. So this is the maximum height for theta is equal to 30 degree. Then for theta is equal to 60 degree, maximum height for 60 degree, same thing, but we'll substitute 30 with 60, sine 60 degrees square by 2g. So here we have u square sine 60 degrees is root 3 by 2 whole square by 2g, which is equal to, it will be 3 by 8 u square by g. So here if you see, Hmax for theta is equal to 60 degree, or we can write it as 3 into 1 by 8 u square by g. So 1 by 8 u square by g is nothing but the maximum height for theta is equal to 30 degrees. So it is 3 times that. So we have experimentally proved that, mathematically we have proved that Hmax 60 degree is 3 times Hmax 30 degree. Okay, the height thing is proved. Now the horizontal range. Now the formula for horizontal range is u square sine 2 theta by g. This is the formula for horizontal range. Okay, now for, there are two cases, theta is equal to 30 degree, theta is equal to 60 degree. So for theta is equal to 30 degree, horizontal range r subscript 30 degree is equal to u square sine 2 into 30, that is 60 degree by g. Again sine 60 degree is equal to root 3 by 2, so it will be equal to root 3 by 2 u square by g. This is the horizontal range for theta is equal to 30 degree. Next, for theta is equal to 60 degree. Range for 60 degree is equal to u square sine 2 theta, that is sine 2 into 60 degree, that is sine 120 degree by g. So sine 120 degree is also root 3 by 2, so it will be root 3 by 2 u square by g. Okay, so here in both the cases the horizontal range is the same, root 3 by 2 u square by g. So here we have proved mathematically from the formula that r 30 degree, range for theta is equal to 30 degree, is the same for theta is equal to 60 degree. So which was asked to prove in the question. So this is the first proof. Maximum height for 60 degree is 3 times the maximum height for 30 degree, and both the cases the horizontal range will be the same. Okay, so the situation is something like this. Suppose the ball or the projectile is launched at an angle of 60 degree, let's say. Okay, 60 degree, it will go 3 times the height as that for 30 degree. Theta is equal to 30 degree. But in both the cases the horizontal range will be the same. Okay, horizontal range is the same in both the cases, but in this case H max for 60 degree it is this much, and this is H max for 30 degree, this much. So 60 degree is 3 times H max 30 degree, in both the cases range is the same. Okay, so this is the situation. Okay, so here we have done. So here is another question on projectile motion with angular projection. So it is given that a ball is thrown at an angle theta and another ball is thrown at an angle 90 degree minus theta from the same point with respect to the horizontal direction with velocity, the initial projection velocity of 39.2 meter per second. The second ball reaches 50 meter higher than the first ball, which means 50 meter higher than the maximum height achieved by the first ball. So we have to find their individual heights. Okay, so first let us write the important things here. So the whole question, it revolves around maximum height. So the formula for maximum height, H max, is equal to u square sine square theta by 2g. U, initial projection velocity, theta, angle with respect to the horizontal axis, g is acceleration due to gravity. So the first ball, let's say, is thrown at an angle theta. Okay, so it achieves a certain height. Okay, H max 1. Okay, so H max 1 for the first ball is equal to simply u square sine square theta by 2g, the same, this thing. Then H max 2, the second ball, which is thrown at an angle 90 degree minus theta, this. So this is H max 2. Okay, so here it is, H max 2 is equal to u square sine 90 degree minus theta whole square by 2g, which is equal to sine 90 degree minus theta is cos theta, so it is u square cos square theta by 2g. Okay, so here if we make the substitutions, okay, we'll make the substitutions later, okay, not now. Okay, so now according to the question, H max 2 is 50 meter more than H max 1. Okay, 50 plus H max 1. Okay, so this is the first equation, this is the second equation. So now if we add 1 and 2, that is H max 1 plus H max 2, that is equal to u square sine square theta by 2g plus u square cos square theta by 2g. So we'll have u square by 2g common, and then sine square theta plus cos square theta, which is equal to 1, so which is equal to u square by 2g. Again, in place of H max 2, we'll substitute 50 plus H max 1, because H max 2 is 50 meter higher than the maximum height achieved by the first ball. So here we'll substitute, let me use a different ink, H max 1 plus 50 plus H max 1, bringing both sides into a common variable H max 1, this. So here it is, u square by 2g, will substitute the values because u, the initial projection velocity, is given 39.2 meter per second. G is nothing is mentioned, so 9.8 meter per second square. So it will be 39.2 square by 2 into 9.8. So which is equal to, it is coming 78.4. this, that implies 2 H max 1 plus 50 is equal to 78.4. that implies 2 H max 1 is equal to 78.4 minus 50, which is equal to 28.4. that implies H max 1 is equal to 28.4 by 2, which is equal to how much? 14.2 meters. That is the maximum height achieved by the first ball, 14.2 meters. So let me write it down here. The first maximum height, that is the maximum height achieved by the first ball, is equal to 14.2 meters. Then H max 2 is 50 meter higher than H max 1, 50 added with H max 1. So it is 50 plus 14.2, that is equal to 64.2 meter. So H max 2 is equal to 64.2 meter. This. Okay, so here we have got both the results, the maximum height achieved by the first ball, the maximum height achieved by the second ball. Okay, so this is the thing. So this whole question, it revolved around this maximum height, this concept. So here remembering the formula, recalling the formula, that is very important in order to solve these kind of questions. Okay, so this is it.